Hi guys. Today we're going to go through correspondences, which is our name for when we talk about whether a function or a relation is one-to-one, one-to-many, many-to-one, many-to-many. So we're going to do it in two contexts. One, we're going to do just graphs, so real numbers versus other real numbers. Will be our two sets, and the other one we're going to do is, because I do like to keep it abstract to make sure you understand what it means in a broader context, we're just going to do two sort of weird sets of things. So I'm going to go with people in my class, so 11 MME05, and you can imagine that I haven't listed them all here, but you can imagine all the students' names are there. And then the second set I'm going to look at is just a bunch of websites. So it could be, let's say it's all the websites on the internet. So it's a big set, but there you go. So we're just going to go through what each of these meanings are, and then we'll make a little summary page, and we'll be done. Should be a pretty short video. Alright, so let's first do it in the context of graphs, and then we'll come back to the more abstract case. Alright, so thinking about graphs, let's just go through them one by one. So we'll start with one-to-one. Okay, so a one-to-one graph is a graph that passes both the vertical line test and the horizontal line test. And what I mean by that is that anywhere you want to go along that graph, you can always draw a horizontal line and a vertical line which only cuts the graph once. The reason this is called one-to-one is the idea that each x value, the first one, gets mapped to a single y value, the second one. So if we look at this point here, we'll say this x value gets mapped to that y value and only that y value. You might be worried about this little section in here, but I can assure you that that is also a unique one. We could zoom in and confirm that, and it doesn't matter how far we zoom in, we're never going to see that line actually touch the graph twice. Not sure we can get in close enough to do that. Okay, so let's move on to the next one. The next one we're going to look at is one-to-many. Why is it called one-to-many? Well, the idea here is a single x value, so let's say x equals 4, gets mapped to two different y values. So there's the one up here, and then there's also the one down here. So this is a graph that passes the horizontal line test, but fails the vertical line test. So that's one-to-many. The next one we're going to look at will be many-to-one. Here's many-to-one. Many-to-one is the idea, now this is the name of this one's a little bit more confusing. The idea is many different x values map to a single y value. So we have -1 maps to 7.813, and so does 6.658. So we have two different x values, which is 2 is many, mapping to the same one y value. This is, by the way, a function. Because it passes the vertical line test, it just fails the horizontal line test. And then lastly, if we've had one-to-one, one-to-many, many-to-one, then we must have many-to-many as well. And that one is, this case, the weirdest looking graphs of all, many-to-many graphs, and they are graphs that fail both the vertical and the horizontal line test. Now notice that it doesn't have to fail it everywhere. If it just fails it in one place, then it's failed. So at the moment we're passing the horizontal line test, but if we move up here, then now we're failing it. So we're crossing it 3 times here, 1, 2, 3. So we've failed the horizontal line test, and we've also failed the vertical line test, well, almost everywhere along here. So these are probably the most rare ones you're going to come across. Where you'll see this most often is actually probably in circles. So circles and ellipses are an example of a many-to-many relationship. Alright, let's go back and let's have a look at the slightly more abstract case as well, and then we'll make a little summary page. Okay, so, oh look, I already made the summary page. Okay, so what would it mean in the context of these abstract sets? Let me remind you what they are. It was the people in my methods class and a bunch of websites. Those are my two sets. Okay, so I'm actually going to start down here at many-to-many. What would a many-to-many relationship look like between these two sets? Well, something like, what websites have you been to this week? So there would be a relationship between Tyler might have gone to 5 different websites, but some of those websites Cindy might have gone to as well. So there's all sorts of relationships running everywhere, multiple people going to the same website, multiple websites from a single person. So many different people mapping to many different websites, and it's a mess. Okay, what would a many-to-one relationship look like? So that would be a question like, what was the last website you visited? Why is that a many-to-one relationship? Well, everyone only gives one answer to that. So that is actually a function, because if you give me an input, I can give you a single output. So if I were to say Nived, there's only a single answer for Nived, and maybe the last website he went to was Reddit. Right, and then I might go, okay, Katrina, let's plug in Katrina into my function. But she might also answer Reddit. So it's still a function, it's fine, but it's not a one-to-one function. It's multiple different things mapping to the same sort of Y value. So that is a many-to-one relationship. What would a one-to-many relationship look like for this abstract set? Something like, who was the last person to visit such and such website? So that's a different sort of question, because while each website can only come up once now, so that's like our Y value, each Y value along this graph here only comes up once, but the same X value, the same person, might come up multiple times. Bhavesh might have been the last person to go to Wikipedia, and the last person to go to Jack Plus Online, where their online textbook is, and also the last person to go to Reddit. He might have just been on the internet last. Okay, so that would be a one-to-many. One X value is mapping to many different Y values. And then lastly, back to the most simple ones, or what you might think of as the most simple relationships, which are one-to-one relationships. So what would that look like between our people and our websites? Well, it would have to be a unique website that belongs uniquely to you. So it would have to be something like, what's your Instagram page? So one person maps to a single website. It can't be a question that allows multiple people to go to the same website, or multiple websites to have the same website to have multiple people coming from. Yeah. So we've got a bit of a summary page here. I'll post this up as a picture on the website. But basically, one-to-one passes both horizontal and vertical. Many-to-one passes vertical but not horizontal. One-to-many passes the horizontal line but doesn't pass the vertical line. And many-to-many fails both. Which ones are functions? Remember, it's all about the vertical line test for functions. So this guy's a function and this guy's a function.